Welcome everyone. Yeah, how's it all going? How's everyone finding? Are there any comments on ZK roll-ups? I'm interested to hear. I'm pretty intrigued by ZK or roll-ups myself. I enjoyed yesterday's session. Yeah, hi everyone. We just got 30 people in. We're gonna wait. Probably got another 10 or so to get in, and then we'll kick it off. Yeah, how did everyone find yesterday's session? If you found it good, maybe give a thumbs up. If you found it not good, maybe give a thumbs down. Hopefully nobody found it not good. I think it was good. That's good. Loving the engagement. As we said, this is the best thing I'd say about Encode is the cohort and the community and the engagement. So please keep the engagement up. Very happy everyone's loving it and rewatching it. Keep your groups up. I'm really enjoying that. If you've got any questions, just ask me. I can help you out. Lauren's can help you. We're here to run a really good program and kind of boost Web3. I'd say. I agree. ZK knowledge or magic. I agree with everyone here. Okay, cool. Lawrence, I think we can head over to you if you want. There might be a couple people filtering in a little later. I know one or two people have excused themselves. But yeah, pretty much over to you.
All right. Thanks, Jake. Hello, everyone. Yeah, love to hear that feedback. I'm glad you enjoyed it yesterday, and we will do a little more. So we'll go into ZK rollups in more detail later on in the course as well. So we'll have a look at those when we talk about scalability. Cool. So yesterday, very theoretical. Today, it's a much easier one. We're going to just review some of the development tools, just introduce you to development tools that you can use when you're writing contracts. And then most of the lesson it will be back to you and give you a chance to work on the homeworks as well. So if you'd like to fill in the poll again to let me know how many of the homeworks you've done, that's useful to know. What I'm aiming to do is to introduce one of the solutions tomorrow, I think from homework 4, I think it will be. And then the larger one, homework 5, we can do perhaps on Monday, and maybe homework 6 if people have finished it then as well. Okay. All right, so let me share my screen. Okay. So what I want to do today is it's a much easier lesson. It's really just a nice gentle review of some of the development tools that you will find useful when you're developing in Solidity. Some of the syntax you will see may not make much sense now, but we will cover Web3 in another lesson, so it will make more sense then. But I think it's easy enough to understand. It's readable, so you shouldn't have any problems with it. And you'll see that when we talk about Truffle. But let's start with Remix. And I think this is probably the environment you're perhaps most familiar with. We did have an introduction to this last week, so I don't really think I have anything else to add to this, other than encourage you to have a look at some of the plugins. The one I mentioned yesterday, Socrates, is at the bottom there. We will look at Yule and Yule Plus right at the end of the course. But some of the other plugins that you may find interesting, there's some tutorials in Learneth. I haven't tried these out, but I know they're there. The gas profiler is useful, but we will also see this in Hardhat, and we'll definitely be using this when we look at optimization. We'll have a couple of lessons about that. The flattener is quite useful if you're trying to verify your code on Etherscan. And then the debugger I got activated there. I tend not to use it a lot because, well, when we talk about Truffle and Hardhat, I'll explain the kind of the workflow there. But it can be useful if you're looking for, if you've got something that you don't understand, and maybe maybe an optimization or something that is not making sense, then it may be you would need to use the debugger to go into find more details. But I don't tend to use it a great deal, I have to say. Okay. So that's Remix, and it seems it has over the last year or so improved quite a lot. There's been quite a lot of changes to it, and one of the most useful ones is the ability to add log statements into your contract code. Now, this used to be something that was a feature of Hardhat only, and as such, it was one of the good reasons for moving to Hardhat. It is, it may not initially sound really useful, but it is when you're actually writing contracts, it's very useful to be able to log statements to the console, because it's quite difficult often in a function to understand what's happening and to understand maybe the state of some variables. And you can get around this. You can, for example, use events to show what the values are of some variables, or you can even kind of have extra variables in your contract you set, and then you can read those. But that's a bit cumbersome, and really it's adding extra things into your contract that are just there for testing, which is not a good practice, really. So being able to have log statements in your contract is really handy. And yeah, as I say, now this used to be just in Hardhat. Now it's available in Remix as well, and it will certainly save you time when you're trying to work out what your code's doing. Okay, but I think unless people have questions about Remix, I don't think there's much more to say about that. It's quite straightforward. Perhaps I could mention that what we tend to do, or our workflow, we tend to use a mixture of tools. We mainly use Hardhat, but we also use Remix as well. And the reason for that is that Remix is quite useful for getting instant feedback, because it's a UI, and as you type the contract code, the Solidity, it will tell you if you've made a compile error. So it's quite useful for that. Whereas what we're coming on to next, Truffle and Hardhat, they're command line based, so they're perhaps slightly less user friendly. So it is quite useful to do a mixture. So we tend to use a mixture of Hardhat and Remix. That's certainly possible. Okay, but I'll start off. I'll go to the next tool that which was really one of the dominant tools for a long time before Hardhat came along. Although I think Hardhat has become more popular now, but Truffle was introduced quite a few years ago, and it's a very useful environment. It really helps you do a lot of things, especially around testing and deployment. Now, if you want to use this, you will have to, if you want to use it on your local laptop, your machine, you do have to install the packages. And because we know that this can be problematic for some people because of differences in versions, not everybody has the same versions of npm or a node or nvm, whatever. And sometimes people have restrictions on what they can install locally. So to help you out, what we've done is created a Git pod. So what this is, you can open this in your browser, and it looks like this when you open it. And what it is, it gives you a development environment that we've created based on a repo, and it runs VS Code. So that's what you're seeing here. You can if you click on the bottom left of the screen, you can go to a dashboard. So I'll just do that. And this shows the workspaces. So what you just saw was one of the workspaces. You can create new ones and have workspaces for different repos. If you don't use your workspace for a while, it'll time out, and you will need to open it again. And then eventually, I can't remember how long they last, but eventually they will get deleted. So just to warn you, if you use this and write some source code, you should remove that, should back it up somewhere else every few days to make sure it doesn't get deleted. But it's a very handy environment to work in. It means you don't have to install anything locally, and we have checked that you can install the things that you need. And so we've got two directories here, one to give you an introduction to Hardhat and one for Truffle. For both of them, what you need to do is to open a terminal. So if you click in the top left here and then go to terminal and new terminal, you'll get a terminal here. You then just need to go into one of the directories like this, and then you will need to install the dependencies. So you'll first of all need to do npm I, and then this will install all of the dependencies for you. So I'll just let that run, but then that should all work without problems because we know that all the versions are set up correctly. Okay. To answer the question about the advantages of Truffle and Hardhat over Remix, so you'll see as we go through Truffle that it is perhaps a more complete environment. Now, this is not absolute because Remix is changing all the time, and they have introduced some of the features that Truffle has. So initially, we moved to Truffle and Hardhat mainly for the unit testing and the test framework they have, which is very useful. But you can now do unit testing in Remix also. The other thing is the deployment process. So Remix is useful where you have perhaps a small project with just a couple of contracts and you can manage that fairly manually. When you have larger projects, it's something like Truffle or Hardhat are good because you can then script a lot of the stuff that you're doing. So when you want to deploy the contracts to test environments or deploy them to the mainnet, you can get all that scripted and automate a lot of that process. So it's really useful in that way in handling larger projects. It is possible to do that in Remix as well. You can deploy everything from Remix, but I find it easier to do it in Truffle or Hardhat, and we'll see that. And can we do this locally? Yeah, I mean, you can. I've provided the Git pod there for you to use if you want to, but there's also instructions of how to install it locally as well. And migration I'll come on to in a moment. So Truffle is part of the Truffle suite. I'll just show you what that looks like. So there's a number of aspects to that. There's Truffle itself, so that's for creating contracts. Ganache we will also see in a moment. So this is a little blockchain that runs locally. And then there are also some extra tools around front ends as well. And one of the nice things about Truffle is these things called boxes. I'll just show you that. So these Truffle boxes are sort of boilerplate projects that you can use, and they're written for different use cases and different to use different technologies. So you can see here. So for example, if you want to try Optimism, the layer 2, there's a box to get you started with that. There's boxes to help you write a front end in React Native or in Vue or React. One of the easiest ones, and one I tend to use because it gives you a nice simple framework, is the Webpack one. And that is useful because you can use this sort of boilerplate project, and it will create a token for you, but also the front end for that. So it'll do everything to create the sort of the most basic type of decentralized application for you. So you have the contracts, it has some tests, but it also has the front end code as well. Now, you may not, in your own projects, you would probably want to, start from scratch and do things differently, but it's quite useful to have these to see and to check how it is done. So you can look through sort of examples of the code. But there are lots of these boxes anyway, and they're easy to install and try out, and they cover a great many different technologies. I mean, Nightfall, it uses zero knowledge proofs. Scales, different blockchain. RSK, Rootstock is a blockchain that integrates with Bitcoin. So lots and lots of possibilities there. Besu, that's part of the Hyperledger project. Yeah, so it's worth having a browse through the Truffle boxes and trying them out. Okay, so that's what Truffle is in general. And when you start a Truffle project, it follows a particular structure, and it's similar to the structure we get in Hardhat as well. So we have folders for contracts, migrations, node modules. Obviously, that's for your packages, and then there'll be a test folder, and then the sort of the configuration folder. So I can show you those in here. So there's our contracts folder or directory. It's got a couple of contracts in it. We have a migrations folder, a test folder, and then we have the package JSON for your node modules, and then the main config file. This is Truffle config, and within this config file, you can specify things like the version of the compiler that you want to use, and you can set up different networks as well. And I'll explain more about those in a second. So the contracts directory, that is where we write our contracts. So in here, we've got an example contract called Volcano Coin that we haven't sort of written any code for. There is also a contract in there called migrations, and you need to leave that one in there. This is provided by Truffle, but it is needed by Truffle for its deployment. So yeah, you just leave what is in there already. And so that's the contracts directory. The migrations directory is there. For this allows you to write some migration scripts, and it supplies you the boilerplate project will supply you with an example of an initial migration. And what this does is it allows you from the command line to kick off the deployment, and you add in lines here to tell it to deploy the different contracts that you have. So you can see at the top here, we create some sort of handles to the contracts we have, and we use this particular syntax, which I'll come back to in a second. And then in this function, we then deploy these contracts to a particular network. So whichever network your Truffle is configured to use, then this will deploy those contracts to the network. So you can see this is sort of where the start of the advantages of automation comes in, because you can set up many contracts here. You can also set up dependencies between the contracts. So if, for example, you deploy one contract, but you need the address of that to be used in the constructor of another contract, then you can specify all of that within your migration script, and you can make these scripts quite complex. There's this initial one that you use, and then you can add more scripts, and they run within the order that you specify by numbering them. So it's often useful to have a number of these scripts, and you can miss out some of the scripts in the order. So you could run, say, scripts 1 to 3, or maybe you could start at number 2, whatever you like. There's lots of flexibility there for you. So yeah, to explain the artifacts, when you compile your contract, it will create things called artifacts, and these are they contain a number of pieces of information. Part of them is the ABI. Now, if you remember when we originally looked at Remix, you saw the ABI, and this is a JSON object that lists out details about your contract. So it's saying what the functions are in your contract, what the arguments are to those functions, and all the details about your contract. And these are needed when we want to deploy contracts and when we want to interact with contracts. So those when we compile our contracts in Truffle, then it builds some artifacts, and then those artifacts are used later on when we're deploying and testing our contracts. So that's what the artifacts mean there. The migrations.sol, this is something that's supplied by Truffle. You don't need to use that. It's used by Truffle to keep track of the contracts that you've deployed and which next networks you've deployed them to. You just when you create a project, it gives you that, and you just leave it alone. You don't need to think about it. It also gives a line for that in the deployment, and again, you just leave that, let it deploy itself. You don't need to think about that. Okay, so that's the migrations. Yeah, and then once you've deployed your contracts to a particular network, then you can test them. And this again is one of the advantages to Truffle or Hardhat, is that you can start to write unit tests. So there's a very simple example of a test here, and this uses that Chai and Mocha frameworks, I think. So these are sort of standard frameworks, they're not specific to Truffle or to Hardhat. These are ones that are quite well established. But what it does is it allows you to build up very large test suites of unit tests, and I really cannot emphasize enough the value in doing this. And we tend to follow sort of test-driven development practices. I'm not saying we're perfect at that, but we tend to try to do that, and so we end up with large suites of unit tests, and it's very useful because what that allows us to do is we can refactor our contracts with quite a lot of confidence, because each change we make, we can then rerun our unit tests and make sure that we haven't broken anything. So that's one of the big advantages, I think, to using Truffle or Hardhat, is the fact that you can build up these big test suites of tests and rerun those, and help you when you're refactoring. And these are written in JavaScript. You can write test scripts also in Solidity if you want. I find that JavaScript is easier, is a little bit more flexible, but you also can write them in Solidity if you prefer. And the question about using Truffle or Hardhat, it's like choosing between Angular and React. Pretty much. I would say Hardhat is more popular now, and it's kind of I think it's perhaps leading the way more than Truffle, but both do roughly the same kind of things, and it's not difficult to migrate from one to the other. If you know Truffle, it's quite easy to start using Hardhat. Or the other way around. In fact, I'll come on to how you can kind of move easily between the two of them when I talk about Hardhat. So that's just just explain the directories you have. Then in terms of networks, you can look in your Truffle config, and you can set up a number of networks and give them names. So you can see here they've commented out various networks, but you can set up ones for development. You could set up ones for the test nets, such as Robston. You can set up ones for the production network, whatever you like. And then when you're interacting, when you're deploying contracts, you can specify on the command line which network you want to deploy the contracts to. So again, it's great for automation. You can test your deployment process and test that it deploys correctly to a test network, and then that will give you confidence when you want to deploy it to the main net as well. And you can see here the details that you need to specify when you specifying a network. So you need to specify a URL. So you're connecting to a node on the network, and it needs to know which port to talk to, and this is the default value for that port, for speaking to nodes on Ethereum. And then you can specify a network ID if you want to, or you can leave that unspecified. And what we shall see is one common practice is that you run the program called Ganache, which sets up a little blockchain that runs locally. And so that would be what you're doing here. You're connecting to the machine that is you're connecting to the network that is running locally on your machine. That way you don't have to worry about interfering with other people's contracts. It's just, or people interfering with your contracts. It's just completely contained within on your machine. But it is perhaps a more featureful blockchain than you get in the JavaScript VM. And in fact, if I can, maybe I'll try and start that up. So this is starting up Ganache. And so you started from just using NPX. And what this does is it gives you some accounts that have a balance of Ether. So these are the addresses, and then the private keys for those accounts if you need those. It also gives you a mnemonic if you want to set up a wallet. Now, it is now the case, I think, that every time you start Ganache, it gives you a fresh set of accounts. It used to be the case that it gave you the same set of accounts, and that was a security problem because people then started to use the same accounts and the same private keys in Ganache as on production, and people then were able to exploit that. But now it gives you new accounts each time. But I should just mention that again, of please never use these private keys anywhere else. They just use them when you're testing, and be careful not to use them anywhere else. And then, yeah, that's then listening, waiting for you to send interactions, to send transactions to your local network. There is also an application for Ganache, so there is a UI as well. If you want to look at that, if you go to the Truffle Suite site, you can then go to Ganache and see how. Just go there. You can download that as an application, and it gives you a nice UI, but essentially it's doing the same thing. But it gives you more details about the accounts, and then you can use it to look at the transactions. So it's running a local blockchain for you, and you can get lots of details about that. It's, in terms of when you're testing, it's a more similar environment to a test environment or to the mainnet than you have if you're deploying to the JavaScript VM in Remix. So it is a good idea to use something like this when you're testing as a sort of intermediate step before you move on to the test networks. Okay, so that's that's Ganache and how you set it up in your Truffle config. Yeah, so I've just gone through that. Oh yeah, and that's a screenshot as well for you. And then the Truffle console itself, if you can do another terminal and then run npx truffle console, which allows you then to interact with Truffle. It also can start up a blockchain as well, but then you can issue commands for Truffle to do things. So you can say Truffle compile, and it will compile your contracts. You can say Truffle migrate, and it will deploy those contracts to whichever network, etc. When you compile your contracts, this is the kind of thing that you will see, and it is just a command line thing, and then you will find that it builds these artifacts. So it's these JSON objects that represent the details about the contracts that you've written. So yeah, that's just some details about the ABI. I've already mentioned the migrations. Just to reiterate, if you want the migrations to deploy your contract, you need to add in a line like this one here. So we're saying we do an await and then deployer.deploy and then the name of the contract. And then that will deploy that particular contract to the network for you. And here's an example of what you can see in the artifacts as well. So it keeps track of the details about the contract and the networks, and once it's deployed, which network it has been deployed to, and the address on that network, etc. Okay, and if you do the migration, you will see this kind of information in the console from Truffle. It will tell you the network, an ID if that's useful for you, details about the network, and then it will sort of give you a running commentary of when it's doing the deployment. So you can see that there's a transaction used for the deployment, and then that transaction deploys your contract to a particular address. So you get the contract address, and it tells you the account that is doing the deployment, etc., and the cost of all of that. And it will display all this for each contract that you're going through, and then give you a summary of all of those. So the ABI is used when you want to interact with a contract. So, but Truffle uses it it builds up this artifacts, which includes the ABI and other details. And so Truffle keeps track of the deployments that you have done. And it is possible as well with Truffle to kind of rewind the migrations as well, if you want to. So it's just, so Truffle allows you to do that, but the ABI is just there when you want to interact with the contract. You don't, I don't think you actually need it to deploy the contract itself, but it is used. It is added to the artifacts, so the artifacts contain other details as well. Okay, just some tips there if you have get some errors, and then details about if you want to set up Truffle, then there's some details here of how to go about it. And this is what the tests look like in Truffle. So once you've compiled your contracts, you can then migrate them to maybe Ganache or to a test network, whichever is appropriate. But then you can run the test command. So you can do Truffle test, and it will run through the unit tests. And this is the type of information that you'll get back. So it will give you a summary of the number of tests that passed and the number that failed, and then it will tell you if you have some tests that fail, it will give you details of why that test failed. So if you're used to unit testing, this should be familiar to you. Okay, you can specify which tests to run. So if I go back to our test, you can see that we have that IT at the beginning there. You can use that to specify the test should be included. But you can expand on it. So you can say IT.only, and then only that test will be run and none of the other tests. Or you can put an X in front of it, and then that particular test will be excluded. Now, I've only got one test here, but if you imagine you had 100 tests, it may be, if you're trying to test a particular thing, it may be better for you to exclude some of the initial tests when you're running the suites initially. So if you want to do that, you can put an X in front of it like that, and then that would exclude this particular test. Okay. As well as testing that something has worked correctly, you can test for errors as well. So you can test that your contract will revert. So if you remember, we were talking about require statements and errors a couple of days ago. Now it's important if you have require statements in your functions, you should test that those actually work and do work as you expect them to. So when you're running your unit tests and when you're writing your unit tests, you should always have tests to where you put in incorrect inputs and then check that your contract does revert correctly for those. And there's an example here which shows you how to do that. So you can tell your the unit test to expect your contract to revert, to throw an error, and then you can check that that error is the correct one, is the one that you expect as well. So you could have that as one of your tests. You can also put in tests that particular events have been omitted. So you should use events. You should have lots of events in your contracts. They're very useful. And then you can check in your tests that these events have been produced by your contract at the appropriate time. And you can check the values that are reported in the events as well. Now, one thing to remember or to point out is that when you're writing your tests, you're typically or Truffle in general uses the sort of similar syntax to Web3.js. So this is a JavaScript library that allows you to interact with contracts, and we'll cover this. I think we'll cover this tomorrow, actually. But it doesn't use exactly the same syntax. So it's fairly similar, but there are a couple of places where it's perhaps simplified the syntax. So, for example, when you're calling a particular function in your contract, you can use this type of syntax where you have the function name here. So the function is called total supply, and then you do dot call and parentheses. So you can use that syntax, but with Truffle, we don't have to. We can just use the contract, the function name without the dot call. So it's similar to the Web3 syntax. I mean, I would say 95% of it is the same, but they have simplified it a little bit. So just to be aware of that it is can be slightly different. Yeah, the question about jest, I don't think this is jest. I think you can include jest in some of the frameworks as well. But no, this is using Chai and Mocha, I think. So which I think are different from jest. Yeah. Sorry, that's already been answered. So maybe. Okay. Yeah. Yeah. So the typical workflow that we use is to maybe start in Remix, to start writing some code, and maybe explore the way that the contract will work. And it gives you feedback about your syntax. Once you're a little bit more sure about your contract, what it's going to look like and the syntax, move to Truffle and start writing unit tests and sort of doing proper maybe test-driven development if you follow that. But build up a big suite of unit tests, and then that gives you confidence for refactoring. And then you can start to write maybe a user interface for this. And we also use continuous integration. So when we're using Git and we commit to our repo, we then have a set of tests that run against all the contracts to make sure that we haven't introduced a bug. So there are tools to do that. And yes, you do need to instantiate an instance of a contract to when you do the unit tests. Yeah, you do need to do that. I haven't got the example in the test there. I'm not sure. Maybe I've got it in Hardhat, but yes, you do need to do that. Okay, so there's some links there for more details about Truffle. I'll go on to Hardhat. This is very similar. I don't want to spend too much time actually, because I want to give you time to go through some of the homeworks. But it's good. Yeah, you have this ability to use console log as well. It does give you a little bit more detail with stack traces when you're running tests, which can be handy. But it does give you more options as well. So, for example, we'd been using Truffle and Web3.js as the libraries to interact with our contracts, and so when we moved to Hardhat, we used particular plugins to Hardhat that still followed the way that Truffle and Web3 worked, to make our lives easier, to make it more familiar. By default, it uses different packager. So it uses Waffle and Ethers. So we will cover these. So I mean, particularly Ethers. This is the library that is used by Hardhat for interacting with contracts. But if you want to, you don't have to use those. You can use the Truffle and Web3 libraries instead. If you've already used those, that might be the easiest way to then start using Hardhat. And as you can see, this is a timeline for Truffle and Hardhat. So you can see Hardhat is newer and has became more popular. I think it's overtaken Truffle now in popularity. Okay, again, you can try this out in Gitpod. So the other directory we've got here is Hardhat. It's very similar, really, in approach to Truffle. There's some details here if you want to install it yourself locally. It comes up with this little sort of set of instructions on the command line. It allows you to create a sample project or an empty project if you want, and fills in various details for you. And depending on whether you want to use Ethers and Waffle or Web3 and Truffle, you can specify different ones in the config. But it's very similar to Truffle in that sense. So we have this Hardhat config file. Again, you can specify the version of the compiler that you want to use. You can specify the networks that you want to use as well. It gives you, it shows you some of the options you have when you're using Hardhat on the command line. So you can use compile to compile your contracts. You can use console to get a console to interact with your contracts or with a blockchain more directly. Again, you can use test to test your contracts. And then also, I mean, flatten you would use if you want to verify your contracts on Etherscan. And it also allows you to run scripts as well. So you can script various tasks in Hardhat and then use the run command to do those. If you take the Truffle and Web3 route, this gives some details about that. So I won't go through that. You can just read through that if you want to do that, but it follows the same syntax as you have with Truffle and Web3. If you don't want to follow that, let me go down. Then this is just more details. Yeah. So then you can use the Waffle framework and Ethers instead, and this is a little bit different in the way that deployment works from what you have used in Truffle. But this is an example here. You use this thing called, or this method called get contract factory, and then you can deploy with that. But a similar kind of approach. You're just scripting all these things to automate the process, make your life a bit easier. And then testing is very similar idea. You have you can write your unit tests and build up test suites. So this, you can group together tests in the describe here. So this describe will then sort of encapsulates a number of tests, and you can put in things that will run before each test. So it may be that before you want to do each test in your test suite, you would then redeploy your contracts so that they're kind of fresh and in a certain state. So you have a way of doing that. And then you can then write tests as well, as you have here, and use the expect keyword here to actually do the testing. So maybe you would, you're testing here some addresses, and you're testing that the owner of the contract is a particular address that you want, and that you can test other details about the contract once you have it. So I think it's quite straightforward. It's quite easy to read. We will go through this when we'll have a whole lesson about ethers and sort of go through in more detail the syntax here. I just wanted to give you an overview at this point. And similarly, as with Truffle, you can test for your contract throwing errors. So if you want to test a require statement, you can do that as well. I'll let you read through that. But one of the great advantages when we started using Hardhat was this ability to do console logging. So I just took some details from the documentation about that. One thing, it doesn't work in pure functions. I don't know why, actually, but pure functions are probably more straightforward anyway to work out what they're doing. But it can be very useful in other functions. And it's good that it works whether your transaction fails or not. So sometimes when you're testing in Truffle, particularly, if your test fails, if the transaction fails, then often you don't get very much feedback from Truffle as to details of what happened. So it's useful that you can use this console log statement to always give you some details of what is happening. There are some specialities if you want to log things in a very particular way. I mean, I've just been logging strings really, or and uints, but you can do things, use these specialized functions if you want to as well, and the specialized formatting if you want to go into that. Yeah, but you can look that up. Yeah, we will probably, I mentioned Tenderly here. I think we'll probably do a lesson about Tenderly. It's such a useful project, but we'll do that when you have a little bit more experience of deploying onto networks. But it's good that also uses, or you can get details from the console log as well in that. There are loads of plugins to Hardhat. I think it's probably more plugins than you get for Truffle. Some of the ones that we've used are things like test coverage. So very useful to know that all of the functions in your contracts are covered by tests. The ability to put the source code onto Etherscan is really useful. The gas reporter, we will see this when we do our lesson about optimization and we look at gas being used. That's very useful. The tracer, makes it debugging more easy and shows more details about events. And then one thing that is useful is that if you've put these console log statements in your contracts, obviously you don't want those to be included when you deploy to production. So there is a package that will remove all of these things for you, which is very useful. If you want to install it locally, here's a quick set of instructions of how to do it. It's very simple, but if you don't want to do it locally, then yes, you can use the Git pod that we've supplied as well to try it out. So that's Hardhat and Truffle. I would recommend using one of those two alongside Remix as you get more confidence in writing contracts. But there are some other ones. One that is more recent but seems to be getting quite a following is called Foundry. This was built in Rust, so it's easy to understand if you know a little bit of how Rust works. But it seems to be quite performant. So they've produced benchmarks comparing it to some of the other frameworks. And so benchmarks, for example, for the testing, how long it takes to run tests. And it does seem to be a lot faster than some of the other frameworks. And then a nice thing that it does that I haven't seen in other ones is that it allows you to do fuzzy testing as well. So this perhaps is a little bit more advanced, but when you come to the stage with your contracts where you're doing more complex testing and you're thinking about getting auditing done and doing static analysis, using fuzzy testing can be quite useful there. It allows you to check for, or it allows the code to check for situations that you may not have thought of. So it gives you more complete testing there. And then another one you may see is Brownie. So this is written in Python. This was reasonably popular in sort of some DeFi projects, and the way you interact with the contracts is using a Python library for Web3 rather than a JavaScript library. So some people do use this, but it's not as popular as the as Truffle or Hardhat. Plugins, yeah, thanks. I think so Luke's replied to that. Actually, there is also something I'll share with you perhaps a little bit later in the course. There's a kind of a template that you can use that is quite a good setup for working with Solidity. It uses Hardhat and has various things set up for you. So I'll share that with you later. Okay, and I think we've answered the other questions. Okay, so that's the end of the review. I would say try these out. Certainly start with Remix and get confident in writing your Solidity in Remix, and then try out Hardhat or Truffle. It certainly when it's useful being able to do tests. So get useful to that workflow of compiling, migrating, and then running tests. I think you'll find when you get used to that they are they're very good tools to use, and you'll enjoy using them. Okay, so I'll finish there. We can use the rest of the session for you to carry on with the homeworks. I have another homework for you if you finished homework 5. So this is to further develop your Volcano coin contract. So I think in homework 4 maybe we set up this payment struct, but we weren't actually using it. So now I would like you to start to use this. And what this is for is that we want to keep a record in our contract of the transfers of the tokens that have happened. Now, this is a little bit contrived, not necessarily what you would want to do in a real situation, but it's there to give you some practice at using structs and arrays and mappings. So what you need to do for this homework is to I think you've already created the mapping. So if you make that variable public, then it creates a getter function for us for that mapping. And then we want to be able to add into the array that we have in the mapping. So within in your contract, you have a transfer function where you're transferring Volcano coin tokens between addresses. So from there, what you need to do is to call to another function. So you need to write a function, which I suggest you call record payment or something like that. And then you can pass to that details about the transfer that you have done. So you can pass to that function the address of the person sending the token, or the person receiving the token, and the number of tokens that you sent. And from those details, I would like you to create a payment record. And what I mean by the payment record is this struct that you created in homework 4 that has a number of fields. I would like you to use these details to fill in the fields and then add these into the array. And so the way the mapping works is that we have an array of these structs, these records for a particular user. So when a user transfers some tokens, we will build up an array that includes the details, one record effectively for each time they do a transfer, and that is held within the mapping. So that struct, sorry, that array is the value that is related to the sender's address. So I would like you to write a function for that to create this record, and then call that when a transfer is done within your Volcano coin contract. Okay. So yeah, you can carry on with that. I'll let you carry on with that as you're doing that or working on the previous homeworks. Please do ask questions if you have them. It's easier to ask those. It's better to ask those in Slido because we've got more room and we can keep the details of that. So yeah, please ask questions there. But I'll stop talking now and then let you get on with the homeworks. Thanks, everyone.
Perfect. Thanks, Ryan. Are you just gonna? Are we gonna call it there? Are you happy to call it there, or is everyone just gonna do on the homework?
Yeah, people can carry on and stay on the call if they have more questions and carry on with the homeworks. Yeah, that's fine. We'll stay here until for the next half hour. Yeah.
Perfect. Just feel free to ask your questions. I'm sure you can just speak on the call, unmute yourself, and ask Lawrence if you want anything.
So to answer the question about the teardown, yeah, that's a good point. So really the contracts are independent of each other. So you can deploy a contract and do some tests on it and then kind of forget about it. So you don't necessarily need to do any teardown in that sense. And so if you just want to redeploy all your contracts, then you can kind of start afresh without having to do the teardown. It doesn't matter that I don't think that you have those sort of contracts still around. It would only matter if there's a contract that you're going to reuse, which is also possible. I mean, you may want to reuse a contracts between tests, but it's up to you how you want to do that. Zero knowledge proofs. I don't know if there's I don't know if there's anything within Truffle or Hardhat, any plugins to help you with that. It depends how you're integrating those. There's Socrates, which is a framework of it in itself. If you're going to use the other kind of layer twos, the roll-ups, then you can use Truffle and Hardhat to sort of write your contracts. I think I'll have to go through that in the lesson where we talk more about roll-ups, because there's quite sort of a lot of involved in that. So I really need to sort of go through show you the diagrams for that. So yeah, but I'll come back to that when we do the roll-ups lesson. So some people still haven't completed the Volcano coin, so I'll post that maybe tomorrow. Yeah, so that you can compare it. Yeah, yeah, the stateful tests. I think this is perhaps a bit of a personal preference. It's one of the. It probably is more appropriate to have stateless tests, but one problem you may find is that the redeploying the contracts each time can take a long time. So the running your tests can become quite long-winded. So sometimes you may want to keep state in the contracts and not redeploy it. But I think typically the reason for that really is just that, just the time taken to redeploy and redo the setup for your contracts. I think, as you say, it's probably better to keep them stateless, but sometimes there's a bit of a trade-off, because it takes so long to get the contracts into the right state initially. To see ZK, yeah. So the easiest way to do it is to use Socrates, something like that. If you want to zero knowledge proof, I'd say that's the quickest way to start out, because that's in Remix, and so it takes you through the process. It sort of has instructions of how to write the code and how to do all the keys and the verify a contract, etc. So yeah, I think that's the simplest way. I don't know about the debugging tool actually on the command line. I haven't. There's a debugging tool within Remix that you can use. I think it is possible in Hardhat, but maybe Luke knows better. And then I don't know which is most popular with Ethers or Web3. Web3 was the original one, I suppose, or the first one that came out. But I don't know if Ethers is more popular now. It became more popular because of Hardhat, but I don't know. I don't know Reach, I'm afraid. Sorry. I think it's possible to write modifiers inside a library. The only difference all the constraints on a library are that it has no state. So I think you should be able to write a modifier as long as it's not relying on any state. Okay, yeah. So Morales, yeah. So that's maybe we should have a lesson about that. It's not something I've really used, but I know a lot of people have used it and found it quite useful as a way to sort of get up and running with writing dApps quite quickly. One of the good things I think about Truffle and Hardhat is perhaps it gives you maybe more control, but I could be being unfair about Morales there. Because I haven't really used it. Similarly with there's InstantApp as well that is quite good, and I think we'll probably have a lesson about InstantApp later on because Carol has used it and will be able to give you a demonstration of that. In terms of finding bugs, we're going to do a few lessons about vulnerabilities and the known vulnerabilities and how to find them. And there are some websites I would recommend for that. I don't know about book. Yeah, I don't know a book that covers that specifically, but we will go into sort of best practices and then also give you the chance to find bugs in a contract that we've written. So typical workflow for Solidity Dev. Okay, I'll put together some notes about that. But yeah, I don't think it's something I can do quite off the top of my head. But yeah, I'll do that. So yeah, thanks for pointing. I was wrong about the modifiers inside a library. So it looks like that wasn't sort of wasn't allowed initially. They're looking at the possibility of in allowing that. Okay. Particularly around diamond storage. Okay. Okay. So the question about the off-chain data. When we go through, we'll have a lesson about sort of layer 2, and we'll go into all of that, looking particularly at the problem of data availability. We'll go through that. It is a very important point, quite a problem. So the misunderstandings or shortcomings question. Generally, I think the Solidity language is reasonably straightforward. In the syntax is easy to follow. The difficulty or the problems that people face are more around the restrictions that are put upon you by the EVM and also the fact that it's a blockchain, and that's sort of one of the hardest things to get your head around. And so the types of misunderstandings you tend to get are thinking that you can sort of around maybe design, where perhaps it's difficult to sort of design your application to be decentralized, and you sort of forget that that's you have to think about that, and often there's aspects of security and privacy that come into that. So people tend to forget maybe that all of the data that is involved in the blockchain is potentially public, and also the people are perhaps not strict enough about security. It's a very hostile environment, the blockchain, and you have to be very careful about it. So those are the sort of the major two things I think that the sort of people find hard to get through. Oh, loop and deleting from arrays mappings. Yeah. Yeah, we'll come on to some of the things about storage they're a little bit tricky, I guess, to follow as well. Yeah, things like that. But we will, particularly when we talk about optimization, but also when we talk about assembly, we will go through in more detail how data is stored in a contract, because it is a little bit unusual. That's a big question. Is decentralization a naive goal? Well, the blockchains do tend to get a little bit centralized. I mean, not just Ethereum, but Bitcoin as well. And as you say, around things like Infura or Alchemy, because people are using a particular company for access to the blockchain. But the things do change, and with the upgrades to Ethereum, we shall see whether that. But if you keep the hardware requirements low, then that does encourage decentralization, which I think is something that tends to be forgotten when people think about blockchains. So it's possible, but yeah, I suppose that you need to also incentivize people to run nodes. So yeah, it's a bit of a uphill struggle, I suppose. Yeah, so and the question about multiple contracts in one file. Yes, so you can define multiple contracts in one file. That's a perfectly valid thing to do. But when you deploy the contracts, yes, they each get their own address. So they are independent of each other. That file is just there really at compilation time. It's just a useful thing to keep the source code together when you're for the compiler. So the question about other chains. So we have done work. I have deployed to other EVM compatible chains, and yeah, well, I think we'll mention those later on in the course. That's one of the great things about the EVM, that so many chains now are EVM compatible, so you can migrate your projects to other chains. We're also doing work. In fact, we're about to do a course about Solana, so there's that as well. Yeah, the CI/CD pipeline with Hardhat. I think the one we use is we use Truffle for our CI. Yeah. Our Solidity project compatible with Polkadot. So there is a Polkadot network called, I always get this wrong around, it's Moonbase or Moonriver, which is EVM compatible. So yes, one of the networks is, but not all of them. Yeah. Moonbeam, sorry. It's completely wrong. Yeah. Yeah, I maybe don't know enough about the sort of Polkadot and parachains, but ETH and Layer 2, I think they are perhaps more tightly coupled than the parachains are. I think maybe the parachains are more general in the way they interact. Yeah, because there's the governance is not really specified on a Layer 2 necessarily. So yeah, it is quite different in that way. Yeah. Yeah, I agree. Personal preference for Hardhat or Truffle. They are quite similar. So the question about the VRF. Yeah, so the problem really with having with generating random numbers just is that if they can be if an attacker could predict the number that you're going to use. So as long as the process that you've got doesn't allow someone to sort of see the seed and then at a later time get a random number, then that would make sense. The drawback really is just, yeah, if you can predict, if someone could predict what the number is going to be. Yeah, I agree. Go for security. Yeah. The question about encrypting data. So just remember that all of the details that you pass to a contract are public. So you cannot use any, if you use a key within a contract to do any form of encryption, then that key would be known to everyone. So yeah, I don't see why you would want to do the encryption within the contract necessarily. Well, no, sorry, that wouldn't make sense. Yeah, so I don't encrypt memory data to hold in storage. Yeah, you'd have to do all of the encryption outside the contract, otherwise the person could see the original data. Unless I'm misunderstanding what you're saying. Okay, I think we're over time, so please do. If you have more questions, please put them on Slido or onto Discord. Otherwise, I'll hand back to Jake, and thank you, and I'll see you all tomorrow. Thank you.
Lovely. Thanks, Lawrence, for a great session. Thanks, everyone, for being so engaging. And yeah, let's keep all the chat up on the group, and see you tomorrow, last day.